So, some of you were asking about problem number 30 on the assignment. Now, this is a very difficult problem. In order to do this problem, you need to use a little creativity. Unless you know what's called the law of sines or cosines, which we haven't learned yet. We will be learning that in the next little while. But without the law of sines and cosines, you got to use a little creativity with right triangles to come up with this. Now, how many right triangles do you guys see right here? 2 of them, right? Okay, you see this one that has the ground, the building, and then the green hypotenuse that makes a 47-degree, 30-minute angle with the ground down here. And then you see the larger triangle goes to the top of the flagpole, down to the ground, and so forth. Makes a 54-degree, 54-minute angle with the to the top of the flag. So we have 2 of them right there. Now, do either one of those 2 right triangles, do we know an angle and a side on any of them, or 2 sides? You either need 2 sides or you need an angle and a side. Do we know any of that? No, because the only length we know is this 40-foot length, and it's not part of a right triangle, is it? Okay, and this is where you have to get creative. This is where you're going to have to create some more right triangles. There's a little trick right here. Anytime you have an oblique triangle, like this one, an oblique triangle is a triangle that's not a right triangle. Anytime you have an oblique triangle, you can create 2 right triangles by taking a line from this vertex, drawing it down to that base right there. You see that? I created 2 right triangles inside that oblique triangle. One right here and one right here. And in this triangle right here, I have this side length of this right triangle. It's 40 feet, and I can figure out the angle up here in the corner because I know this is a right angle, and I know the measure of the angle right here. I can figure it out anyway. And therefore, I can figure this angle out, and I have enough information to find out all of this right triangle right here. Well, if I figure out all that right triangle, I have enough information in this right triangle right here to figure all of it out, including the one that's the hypotenuse for this right triangle down here. And then I have enough information to find out the height of the building. So that's the creativity you have to use. Now, I didn't expect you to get this one, okay? But I do expect by showing you this that you can come up with this. We're going to be doing a little worksheet that has 5 problems on it. That's problems like these, where you have to figure out where to draw in. On a couple of them, you have to figure out where to draw your lines to make additional right triangles so that you can solve them. And it will really help solidify and help you understand these whole concepts right here. So let's do this one right here, okay? You guys, this oblique triangle right here, the one with the 2 green sides and the flagpole, I want you to figure out what the angle right up here in this corner is, right here. What is the measurement of that angle right there? We can look at this bigger right triangle. I have this as a 90-degree angle. This angle down here is 54 degrees, 54 minutes, right? So I can figure out what the angle measurement right here is. What is it? Well, actually, I have 54 degrees, 54 minutes. So what's the angle up in the corner? How am I going to find it? Anybody awake out there? The angle up here in the corner. What was that? Well, you've got this angle down here in this corner is 54 degrees, 54 minutes, which would be 54.9. Is that what? Did you get it by going 54 divided by 60? Yeah, so you had 54 plus 54 over 60 is 54.9 degrees, right? Subtract 54.9 degrees from what? Get this one up in the corner. 90. Do that. 90 minus 54.9 degrees. What do you get? Huh? 35.1 degrees. So this angle up here in this corner is 35.1 degrees. Is that what you said? Okay, so look, I wish we could draw this bigger. I know the length of this side is 40 feet. I know this angle is 35.1, and I want to find this length here, that line we drew in, because it's part of the next triangle. Okay, so from this angle, which side do I want to know? Opposite. Which side do I have? Hypotenuse. What relates opposite and hypotenuse? Okay, good. Sine. So sine of 35.1 degrees equals opposite side. I'm going to call it x right there. X over 40. So I'm going to go 40 times the sine of 35.1. What's x equal to, you guys? What? Sine of 35.1. 23 point what? 00021. You know what? We're just going to go 23. How does that sound? 23. So this is 23 feet. Okay, x equals 23. Now, in this triangle, I can figure out this angle down here. What's this angle right here? This red one down here. Eddie, get out your calculator. What's that angle right down there? How do you figure it out, you guys? What's 47 degrees 30 minutes as a decimal? What's 30 over 60, you guys? Half, 0.5, right? So this is 47. This is 47.5 degrees. So all I have to do is find the difference between these two, right? 54.9 minus 47.5, what is that? Quickly, you guys. Everybody get out your calculator. I'm not doing this for you. I'm doing it with you. Okay, I'm trying to help you out. But you got to pull out your calculators. 54.9. We're taking the difference between this one and this one so we can find this little piece right here. Huh? 7.4. That's 7.4 degrees. Okay, Austin, you got to stop. Okay. I'm having a good morning. Don't make it a bad morning, you guys. Get out your calculators. Wake up. Huh? I get plenty of laughing in my life. Right now, it's not time to laugh. You got to know when to laugh and when not to laugh. Austin, stop right now, okay? 7.4 degrees down here. This angle right here, we got to figure out this length right here because it's part of the bigger triangle. Okay? So from this angle, which side do I have? Or which side do I have from this angle? And which side do I want? That's hypotenuse. It's opposite this right angle. Okay? So sine of 7.4 degrees equals opposite, which is 23 over y. So that's the same thing as y equals what? 23 over the sine of 7.4. Okay, tell me what that is. 178 point what? 577? 0.577? Okay. Now, you guys, can I find the height of the building now? Yeah, I have a side and an angle in there, right? I have this side, I have this angle right here, which is 47.5 degrees, and I want to know opposite, and I have hypotenuse. So what am I going to use? Sine again, right? Sine of 47.5 equals opposite, which is h, over 178.577. So 178.577 times sine of 47.5 equals h. What is that?
131.6607.
What? It should be that right there. Do it again. Oh, it depends on how you rounded it. The book depends on how you rounded it. Some of you guys rounded different. The book has 131.7. They rounded the nearest tenth. Depends on how you rounded the previous numbers. So, did you guys use 0.577? Yeah. Yeah, so that one's probably more accurate. So it's 131.66, which is 131.7, which is what the book had. Okay. That's how you do that one. Okay, you guys, number 27 says the Cape Hatteras Lighthouse on the North Carolina coast was built in 1870 and rises 208 feet above the sea level. Does the year matter? No. You always got to discern which numbers matter and which numbers don't, right? But will the height above sea level that this tower is, will that matter? Yes. Probably. From the top of the lighthouse keeper observes a yacht and a barge along the same line of sight. The angle of depression for the yacht is 20 degrees. And the angle of depression for the barge is 12 degrees 30 minutes. For safety purposes, the keeper thinks that the two sea vessels should be at least 300 feet apart. If they are less than 300 feet, she plans to sound the horn. How far apart are these vessels? Does the keeper have to sound the horn? Let me help you draw a picture of that one. I'm going to let you guys do the problem, though. Here's the shore, right? Here's the lighthouse. How do you guys like my design here? Here's the water. Here's the water. Here's the boats. So you have a barge. And what's the other one? A yacht. Which one's closer, the yacht or the barge? Which one's angle of depression is more? The angle of depression for the yacht is 20 degrees. And the angle of depression of the barge is 12 degrees 30 minutes. So, no, the yacht's closer because its angle of depression is more. So the barge is out here. We'll put the barge out here, right? Because look. Oh, I gotta finish my artwork on here. Okay, that looks more like an arc. Okay, so the angle down to this yacht, we draw a line straight across, and the angle down to the barge have different angles of depression. Okay, the angle to the yacht is more. It's 20 degrees, right? And the angle to the barge was what? 12 degrees 30 minutes. Is that right, you guys? Is that what it says? And the distance to sea level right here is, was it 208 feet? And you want to know this distance right here. You want to know what the length between them is, right? So you have two right triangles, don't you? You know a side length of both of them. Now, keep in mind, I need to know this angle right here and this angle right here. I don't have those angles, do I? Yeah, they should be. 70 and what's this angle right here? Remember, what's 12 degrees 30 minutes in decimals? Okay, good. So that's 77.5. So you know an angle and you know the side of these. So I would probably find this x distance right here, okay? And then I would find this y distance right here. And subtract them. Does that make sense? And you got it. I'm not going to tell you any further than that. You guys can finish that one on your own. Jacob. How come they do minutes and seconds? Well, we are using the decimal. We changed it to decimal. You're saying, why doesn't the book do it? Because if you ever looked up land surveys, you always do it in degrees, minutes, seconds. And so if you're ever going to become a surveyor, you would need to know this. Any engineer would need to know this, like a civil engineer, because anything they do is in degrees, minutes, seconds. They have to know how to reproduce it as decimal degrees. So I don't know why they did it that way in the first place. Someone came up with that measurement, and now we just have to deal with it and change it to decimals. And it's just stuck. I do a lot of stuff where I look at properties and buy them. And I'm always looking at legal descriptions of properties, and they're always done in degrees, minutes, seconds. So other than that, I can't tell you why. It's a hassle because you have to change it to decimal degrees to calculate it, right? And then they have to change it back. I don't know. Those guys, when they originally did it, I'm sure they didn't have to do it that way. Okay. That's it. Okay, so I want you to get out. Did I give you guys all a copy of a unit circle? Okay, get it out and put it in front of you right now. And obviously I have these two that are up at the front of the room. Okay, but I want you to get that one out in front of you. It's a little bit better. It's on the other side, Dakota. Okay, get them out. Put them in front of you guys. Jacob. That's not what I gave you that paper for. Oh, man. Okay, just don't show your mom and dad that. This is what I did in math class today. Yeah. Hey, Jacob, I inspired Jacob. I drew a picture of a building, and look what happened from there, okay? Jake, this is a day in the life of Jacob's math class. I'm in trouble. All right. Okay. All right, I feel like I'm in elementary art class. Oh, wait, I'm sorry. All right. Okay, given, you guys, that the sine of theta equals 1/2, what is the measure of theta? Given that the sine of theta equals 1/2, what is the measure of theta? In other words, let me rephrase that. Sine of what angle is 1/2? Don't get out your calculators. Use your unit circle. Sine of what angle is 1/2? No, sine of what angle? Sine of what angle is 1/2? What's the definition of sine on the unit circle, you guys? It's the y-coordinate. Find a y-coordinate on there. 30 degrees and 150 degrees are the two answers. So everybody look at 30 degrees right here. 30 degrees right here has a y value of 1/2. And 150 degrees has a y value of 1/2. Therefore, 30 degrees is one answer. 150 degrees is the other answer. Any questions? Does that make sense? That's the answer. What are we going back to? Miranda, look. Sine of what angle equals 1/2 is all we're asking. Okay. I want you, okay, we're going to, let me get you right here. Okay, so person A in each group, explain to your shoulder partner what the cosine, when the cosine of theta is 1/2. In other words, cosine of what angle is 1/2? Give you a minute. Okay, good. So 60 and 300 were the answers to that one. Go to number 2. Okay, person B gets to do this one. Okay, so we got that one. 45 and 225 because root 2 over root 2 divided by root 2 over root 2 is 1. Okay, next one. Okay, person A, do this one. Go. Okay, 30 and 330. All right, I just need to write that down for whoever else is watching this. Okay, next one. Last one. Cosecant of theta equals negative 2 root 3 over 3. I want to see who can get this one.
Why you gotta make them so hard? Yeah, and then you start throwing numbers and it gets a fun.
When your group has it, raise your hand. Okay, 2 groups. What is it? 240 is one. What's the other one? Huh? Okay. Okay, good. Watch. I want you guys to watch this. Some of you guys don't know how to do this. Okay, look, you guys, we know that cosecant's defined to be 1 over y, right? Okay, I know that to get something that looks like 2, that has a root 3 in it and has a 2 in it, would probably have a square root of 3 and a 2 in it, right? So it's probably going to be the one that has square root of 3 over 2 in it, right? And this is a negative, so it's got to be somewhere where it has a root 3 over 2 that's negative, and it's got to be a y coordinate. Well, if you look at 240, 240 has negative root 3 over 2. Now, I can check this. You guys got to watch this, please. Sherry, you guys got to watch this, because you're not going to know how to do it without it. Okay, look, if I have negative root 3 over 2, when I have a number divided by a fraction, Austin, what do I do? How do I do this? Go ahead, Austin. Flip what? Okay. Where do I put it when I flip it? I times it by the top number, right? So you guys, you flip it, you times it by the top number, and you're going to get 2 over negative root 3. What's wrong with that? Okay, so we got to rationalize it. So what do we do, Austin? I multiply the top and bottom by root 3. 2 times root 3 is 2 root 3. Negative root 3 times root 3 is negative 3. And I get 2 root 3 over negative 3. So what's my answer? My answer is 240. And is it 300? Yeah, and 300, because those are the two that have a negative root 3 over 2 for the y coordinate, right? How are you going to do it that way? Kind of get the idea? Okay, so that's basically part of what we're doing today. Okay, how to find inverse trig functions. I want you to write this down. When you're looking for an angle, you're finding the inverse. Write that down. When you are looking for an angle, you are finding the inverse of a function. Make sure you have that in your notes. It's very important. So when you go to review your notes, you can remember that when you're looking for an angle, you've got to find an inverse. That will remind you when you're on your test and you've got to find an angle that you've got to use the inverse key. Now, there are 2 ways to write inverses. If you are given sine of x equals root 3 over 2, we're looking for an angle, right? We can write that as an inverse. We can write it so it's solved for x. We do that by writing it like this. Sine with a little negative 1 up here. See that sign with negative 1? That looks like a negative 1 exponent, but it's not. I don't know who came up with this notation a long time ago. I think it's a bad notation, but it's kind of stuck, and it means sine inverse. Don't think of it as an exponent. It just means that it's a symbol for inverse. So when it says find the sine inverse of root 3 over 2, I'm looking for the angle whose sine is root 3 over 2. That's what we're looking for. Now, someone else thought that using a -1 right there was a bad idea too, so they came up with a different way of writing it. They came up with writing it as arc sine of √3/2 equals x. It means the same thing, okay? So these two are interchangeable. These two things, these three things all mean the same thing. You're looking for an angle whose sine is √3/2. That's what you're looking for. By the way, what angle has a sine of √3/2?
300.
No.
330.
No.
No, 60.
60 degrees. It's not a negative √3/2. It's a positive √3/2. 300 has a negative √3/2. No. Okay, so 60 degrees and 120 degrees would be the two answers. Okay? 60 degrees and 120 degrees. Okay, so I want you to turn to your shoulder partner and tell them the two ways to write an inverse. Okay, explain to them in your own words. A, go first. Okay. All right, so you guys, sine of x equals -1/2. The two ways to write that is sine inverse of -1/2 equals x and arc sine of -1/2 equals x. And I left the answers up here. Look at 210 and 330. They both have a y value of -1/2. Okay? Any questions there? Okay, now I want you to discuss in your group what you think the answer to this is. I'm going to give you 30 seconds. Go. Discuss in your group what you think this is. Because you're taking the tangent of the tangent inverse of 6/11. Could. You could do it that way. You're right. There's not a 6/11 on your unit circle, is there? Do you need to? Do you know?
Answer is undefined. 0.545.
I want you to divide 6 by 11. Tell me what you get.
4.49934667217.
Okay. Why is it? How many of you put in your calculator tangent of the tangent inverse of 6/11? And you got 0.545454? And then when you divided 6 by 11, you got 0.54, right? Why is that? Why'd you get the same answer whichever way you did it? Huh? Exactly. That's exactly why. You guys, did you hear what Jacob said? The tangent of the tangent inverse, they cancel each other out. They undo each other. Let me give you an example. Okay? So, you guys, it's just like this. 5x divided by 5. If I times x by 5 and divide x by 5, what do I get? I get x because these two undo each other, right? If I divide by 5, it's 1. Okay? If I go x plus 4 minus 4, what do I get? X, because 4 minus 4 cancel each other out, right? So they undo each other. Just like addition and subtraction are opposites, or inverse operations, multiplication and division are inverse operations. Taking the tangent and the tangent inverse are inverse operations. They undo each other. The answer would be 6/11. Okay, now, what happens when all of a sudden you're taking this cosine of the arc sine? These are not inverses, right?
What's arc?
Arc sine means the same thing as sine inverse. Remember that? We just went over that. So the cosine of the arc sine of 2/3 is what we're going to talk about now. Now, this problem is more difficult. Let me do this one with you, and then I'm going to give you guys something to do on your own. These are not easy. You're going to have to not talk while I'm doing this. You're going to have to pay attention and write this down so you have something to refer to and ask questions if you don't understand it, okay? Okay, because this is not easy. All right, so first of all, I'm looking for the cosine of the arc sine of 2/3. Now, remember that an inverse is looking for an angle, right? So really, what I'm looking for, this part right here all represents an angle, and we're going to call it theta. So really what I'm looking for, you guys, is the cosine of the angle theta. That's what I'm looking for. Okay? Now, I'm given a hint. I know that the sine of the angle theta is 2/3. That's what arc sine of 2/3 means. It's telling me the sine of an angle is 2/3. Now you'll notice that 2/3 is not one of your, it's not a point on the unit circle. Because remember, an arc sine, this is an inverse right here, right? And an arc sine represents an angle. So we're going to just replace it. We're going to rewrite it as sine of theta equals 2/3. Remember this slide back here? Remember this one right here? This one right here? I showed you that sine of an angle is square root of 3/2. That means the same thing as sine inverse equals square root of 3/2, or arc sine equals square root of 3/2. So I just rewrote it from this form down here to this form up here. All I did is took it from this form to that form. We got it? Okay, so I have taken this, you guys, and rewritten arc sine of 2/3 and put it in this form right here. Okay? Now, 2/3 is not on the unit circle, so I'm going to have to draw a triangle. Now, we're going to assume, and it will tell you in your book which quadrant this is. We're going to assume this is in quadrant 1. So what I'm going to do is I'm going to draw a triangle in quadrant 1. I'm going to put theta right down here in quadrant 1. I'm going to draw my right triangle so that one of the sides of the right triangle is laying on the x-axis. That's how we've been doing it this whole time. And I'm going to label sides. I know that sine on a non-unit circle is equal to what over what? What's sine equal to in a non-unit circle? Y over r. Y over r. So I know two things right here. I know y and r. What's y? 2. And y is the vertical distance, right? And I know r. That's the hypotenuse. What I don't know is what x is. And I know that the definition of cosine, which I'm looking for, is x over r, right? So I'm going to have to figure out what x is. How do I find x? How do I find the missing length x? A squared plus b squared equals c squared, someone said. X squared plus 2 squared equals 3 squared. Remember, the hypotenuse always goes on the side by itself. That's 4 equals 9. If I minus 4 from both sides, 9 minus 4 is 5. Therefore, x is equal to plus or minus square root of 5. So x equals positive or negative square root of 5. Now, look, if I'm in the first quadrant, I'm going out to the right. Is it positive or negative? So it's a positive square root of 5. Okay, so now I have x. Now I have my answer. Because remember, originally, I'm asking for cosine. That's what I told you. I'm really looking for cosine. Well, the cosine is x over r. And x is the square root of 5. And r is 3. And therefore, my answer is square root of 5 over 3. How many of you think you could do something like that? A couple of practices and you'll get this down. I promise you. You guys have all the basics for it. If you've been getting all this other stuff, you've got the basics for it. So we got to practice this. Are you ready to do a sage and scribe? Okay, so you're doing this one using a sage and scribe. A's go first. Go. It looks like most of you have it now, okay? So, you guys, when I set up my triangle, I put it over here in this quadrant. This just means the cosine of theta equals 4/5 right here, right? This is the part that lets me set up my triangle. So I know that cosine is defined to be x over r. So we know that x is 4. X distance is the horizontal distance. R is 5. Okay? And the hypotenuse is always r. Okay? If I use the Pythagorean theorem, I figure out that y is 3. And really what I'm looking for is a tangent. The tangent of theta. And I know that tangent's defined to be y over x. I now have y is 3, x is 4. So my answer is 3/4. Okay, good job. You guys got it, because you worked at it. Good job. Okay. All right, now, here's the next question. How do I find angle B when I don't have one of the other angles? I showed you a problem like this last time in class, because I was thinking I needed to show it to you.
Oh, I know.
And I didn't. But let's see if you guys remember. I'm looking for an angle, right? What does that give you a hint? You can use your calculator for this one.
I have it.
That is it. That is not it. Wait, let me see. Well, I think you got your calculator in reading mode. Go to mode, put it in degree, and then hit enter again, and you'll have the right answer. Because you put it in right. Now that is correct. Yep. Make sure your calculator's in degree mode, or you're going to get 0.88, something like that. Okay, hey, you guys, look. I'm looking for this angle right here. If you don't get this, watch. I'm looking for this angle. I have two sides from that angle. Okay? I have the opposite side and the adjacent side. 17 is opposite away from B, right? Adjacent, that's not the hypotenuse. This one right here is the hypotenuse. So I have opposite and adjacent, which is a tangent. So tangent of angle B, I'm going to put B, equals opposite over adjacent. So the tangent of an angle equals 17 over 40. But I put it in my calculator as, I change it to this form right here. Tangent inverse equals 17/14. So I put it in my calculator like that, and I get 50 point whatever. What was it? 50 point what?
That's all you have to do.
527, 528 degrees. And that's all you have to do. If you have two sides of a right triangle, you can find any of the you can find one of the acute angles by doing an inverse. Okay? Just get the right trig function, the right one you need. Okay. Now, what does it mean to solve right triangles? If I have a right triangle, and it says solve for this right triangle, what does it mean to do? It means find all the measures of all the sides and angles. Sides and angles. Write that down if you don't know it. If you know that already, that's fine. Okay? Because in your directions, your instructions today for your assignment, it's going to say it's going to say solve the right triangle. And it means find everything that's missing. On your next test, that's the way it's going to be written. It's going to say find everything that's missing. Got it? Any questions there? Find all the sides and all the angles. Okay, now, I want you guys to solve this right triangle right here. I'm going to give you, I want person B to go this time. Person A went last time. Person B, tell person A what to write. You're a sage. Go. Hey, how many of you guys got this? Good job. I saw some correct answers. Hey, let me just show you guys. Hey, if we use the Pythagorean theorem, let's call this y. So y squared plus 46 squared equals 57 squared is how we're going to set that up. I ended up getting y equals the square root of 1133. Is that what you guys got? Yeah. I checked to see if that would simplify, and the only two numbers that go into it are two prime numbers, 11 and 103, so it doesn't simplify. So you can leave it as the square root of as 1133, or some of you put it as a decimal, 36.0 194. Okay? Either way, in this case, will work. I want you to check the answers in the back of the book when you do it. Okay, to find angle B, I know that the cosine of angle B, is equal to adjacent side over hypotenuse, which I had. So you're looking for an angle, you do the inverse. And you guys got what? Oh, I'm sorry. This up here is not right. I was looking at the wrong number. 33.66. This right here is 36.194, right? If you do cosine inverse. And if you subtract this from 90 minus 36.194, what'd you guys get up here? What? Okay, there's your answers. Good job. Okay, there's your assignment. Notice I only gave you 4 problems. Do you need that right now? That stuff?
Hey, did you ever get your Smart 8 to work?
Let me turn this up.